Hey, what's going on, guys, and welcome back to my channel. In this video we will be looking at what dimensional modeling is. This is an extension of the last video that I uploaded called additive, semi-additive, and non-additive facts. Okay, so let's just get started. So what exactly dimensional modeling is? Well, dimensional modeling is a database design technique optimized for data warehousing and BI analytics. Okay, unlike OLTP, which for hopefully we can review what OLTP is more deeply in further videos. Unlike OLTP, which focus on normalizing data to eliminate redundancy, dimensional modeling intentionally denormalize data. Okay. So what is the main goal of the dimensional modeling? Well, the main goal of this is to maximize query performance and make the data structure intuitive for business users to navigate. Okay. In this case, let's just consider that we have a BI team which want to have access to our data or our database, right? With this, what we can achieve with this is to provide the BI team a more straightforward and friendly way to access to this data, okay? By, of course, modeling this data, right? So the pioneer of this is that it was popularized by Ralph Kimball, okay, with the bottom-up approach, and nowadays is still widely used across so many industries, um, and that's why you have to know what exactly uh, it is, okay. So the core structure of this dimensional modeling is that it uses facts and dimensions, okay. So a dimensional modeling is built around these two fundamental tables. Um, and the first, of course, are the fact tables. And once again, we already covered this in the last video. But just so you know that these sit at the center of the model, right? And these tables contain the quantitative metrics or measurements resulting from a business event, okay? And these are created, built along with foreign keys linking to the dimensions, okay? So these fact tables answer the question, what happened and by how much, okay? These fact tables are highly numeric and highly additive, okay? And some examples of these are quantity sold, total amount, and wait time seconds. So if you want to learn more further about what these fact tables are, I highly recommend you to check the last video that I upload. Um, um, just if you have more questions, okay? So the second core structure, the second fundamental type of table of this dimensional modeling is the dimension tables, of course, because these tables surround the fact table and provide the context surrounding a business process event. Okay, so these tables answer the questions who, what, where, when, and why. Okay, so some characteristics of these tables is that there are fewer rows than fact tables. Okay, but many descriptive text columns that are actually attributes. Okay, and these attributes are used for filtering and grouping these fact tables. Okay, so for example, you can have the customer name, the product category, and the store city in different tables, and these tables and columns will provide context to the fact table. So with these, you can answer the question: hey, how many cars did we sold the last month in determined city? And I don't know. What is the name of the customer who made the most purchases the last month, and so on, right? So these once again are the main type of tables that are the core structure of facts and dimensions. Okay. I mean, of the dimensional modeling. Sorry. So, the common schema architectures for dimensional modeling are the star schema and the Snowflake schema. Okay. So the star schema is the gold standard of dimensional modeling because it's the more used is a more easy to use schema. Um, and yeah, in this star schema, the fact table sits in the center, and as I said before, the dimensions tables connect directly to it. Okay, so no dimension is connected to another dimension. What are the pros of this? Is that this star schema is ultra fast query performance, which means that there's you actually need minimal joins to do analytics, and it's incredibly easy for BA tools to understand. Not only for BA tools, but also for humans to understand. Okay, that's what is widely used and easy to understand. Okay, and the second one is Snowflake schema, which is actually a variation of this first star schema. And in this case, we have tables that are normalized, and hopefully we can also explain in further videos what normalizing the normalize is. But I just want you to think in normalize as split into a table into subtables. Okay. For instance, we can have the product dimension, which might be linked to separate category dimension table. And in this case, we will have the fact table, the category dimension table, which provide context to the fact table. And we can actually have a product which is linked not to the fact, but to the category table. Okay. So some cons of this is that it requires, of course, more joins, and these kind of schemas can severely bottleneck performance in big data environments. Okay. And I brought you some practical examples of this, thinking of an e-commerce platform. In this case, we will have the fact table. Well, let's just think that we want to build to make some analytics of an e-commerce platform. So we can have the fact table where each row represents a specific checkout transaction. Okay. And this table is called the sales table. And as we can see, it contains the time ID, the product ID, the customer ID, the quantity, and the total amount. And we can have our dimensions table. The first one, the dim product, the product ID, the product name, the category, and the unit price. Okay. So this, alongside with dim customer, with dim date, will provide context to our sales table. Okay. So in this case, as you can see, the fact sales table had foreign key named time ID, which is actually used in the dim date table, also named as time ID. Okay, and in the case in the sales table, fact table is a foreign key, and we linked it with the dim date through a primary key, which is actually the time ID. Okay, and that's the case for each of these tables. As you can see, the product ID is actually present in the dim product. The product ID is also present in the dim product table, dimension table, right? Name with this name the same in both tables, and the customer ID is actually present in the dim customer dimension table. Okay, so as you can see, these are the foreign keys, and these are the primary keys. Okay. So in this case, what this conform is a dimensional modeling following a star schema, okay, approach, and yeah, with this we can what we get with this is this, which is the more visual example of what I trying to to explain to you, this is what the dimensional modeling will look like once it's constructed. Okay, as you can see, the dim customer. Uh, Also, dim is stands for dimension. Okay, so the dimension customer table is linked to the fact sales table. Okay, the sales table itself, as well as the dim product, dim time, and I added the dim location, which is not present here, but you can have a more just I added this just so you know that this model can actually grows and expands as your data needs expense. Okay, and also what I wanted to say is that as you can see here, we are using some foreign keys for the fact table and some primary keys in the dim product table. Well, this is intentional, so you understand that this column is linked to this that this table is linked with this table, okay, through time ID, through the time ID column. But just so you know that this is actually not the current state of the cloud development, and more in specific in analytics, because we prefer, as a data analyst, data engineering, we prefer this to be more logical than force these to be mandatory, like physically force these two tables to be linked. Okay, and yeah, that's it. I think that's everything you need to know about dimensional model. Okay, thank you so much.